State and federal agencies, nonprofits, and other groups have spent more than $3 billion over the past quarter century for some 800 projects aimed to protect and improve Lake Tahoe.
Lake Tahoe has reached its highest water level ever, quickly recovering after years of drought. But this rapid rise may come with a hidden danger, a massive fault beneath the lake, now under pressure from billions of tons of water. The fault is overdue for a major quake, and if the pressure finally releases, the consequences could devastate coastlines in minutes, turning the paradise into a disaster zone almost overnight. The hidden fault beneath Tahoe. Beneath the serene waters of Lake Tahoe lies a powerful and largely unseen force, the West Tahoe Fault. This fault runs directly beneath the lakebed for roughly 25 miles, a massive geological fracture that has quietly accumulated tremendous tension over thousands of years. Scientists have studied this fault for decades, but what they've uncovered continues to raise alarm within the seismology community. The fault is capable of producing a devastating earthquake, potentially reaching a magnitude of 7.3, an event far more destructive than many realize. While magnitude alone is striking, it is the fault's condition and history that truly demand attention. Research indicates the West Tahoe Fault has been overdue for a significant rupture for nearly 4,000 years. That long pause means the strain locked within the rock is immense and growing. Billions of tons of pressure press down through fractured bedrock beneath the lake, intensifying the fault's instability in ways few have understood until recently. Despite its size and potential, the West Tahoe Fault remains largely out of the public eye. Unlike California's infamous San Andreas Fault, it rarely headlines news stories or public safety campaigns. Visitors and residents alike see only the lake's pristine surface, unaware that they live atop a ticking seismic time bomb.
Ground beneath California is moving.
We're talking movements that are maybe the width of 2 stacked pennies every year.
In fact, the fault's decades of quiet have bred a dangerous complacency until now. What makes the West Tahoe Fault particularly concerning is its complex structure. It is not a single, clean break in the Earth's crust, but a network of interconnected segments that could rupture in sequence or simultaneously. This cascading failure could amplify the earthquake's power and extend its destructive reach. The hidden geometry beneath the lake turns a single fault line into a web of threat, increasing the challenge for scientists and emergency planners. The significance of this fault extends beyond the sheer energy it could unleash. Its location beneath one of the most popular vacation destinations in the country adds a human dimension to the geological risk. Lake Tahoe draws millions of visitors yearly and supports over 55,000 permanent residents. The tranquility and beauty mask a vulnerability that could transform the area in an instant. Seismologists have prioritized monitoring this fault intensely in recent years, sensing that its quiet period might be coming to an end. Instruments scattered around the basin track every tremor, every subtle shift deep underground. These observations offer a crucial window into the fault's behavior, but the picture remains incomplete and unpredictable. The tension builds relentlessly beneath the water as scientists wait for signs of movement that could trigger disaster. This growing unease sharpens as water levels in Lake Tahoe rise to historic highs. The pressure acting on the fault increases in ways that researchers describe as deeply concerning. It's a developing situation, one where events above the surface directly impact forces hidden below. The fault's response to these changes is becoming impossible to ignore, though the full story of the fault's threat will be revealed later. The central fact is clear. Lake Tahoe sits on fractured ground burdened by millennia of tension. This fault is a silent giant with the potential to reshape the region dramatically. What remains uncertain is when and how the accumulated strain might finally break free. Understanding this fault and its risks is the first step toward grasping the danger Lake Tahoe faces. Although the lake today appears peaceful and still, beneath the surface, the Earth's crust carries a burden that could soon unleash powerful consequences. This tension between calm waters and geological stress is the heart of the story unfolding in the basin. The recent surge in Lake Tahoe's water level adds a new weight to the story, transforming quiet geological risk into a scenario with immediate real-world impacts. Lake Tahoe's dramatic water rise. 5 years ago, Lake Tahoe painted a very different picture. A lake drained nearly to historic lows by an intense drought. Once vibrant shorelines revealed ancient tree stumps, exposed by retreating water, and boat ramps led nowhere as water levels sank farther each summer. Residents and business owners alike watched helplessly as the lake shrank, worried that the drought's grip might never fully ease. Climate scientists voiced grim predictions that California's long-standing water crisis might become the new normal. An unusual transformation started to unfold during the last months of 2022. Atmospheric rivers and relentless storms created massive snowpacks, which covered the Sierra Nevada mountains and led to snow accumulation that reached 200% of normal levels in certain regions. The Tahoe Basin experienced an unexpected water surge when spring brought snowmelt, which sent water into the basin at an unprecedented rate. The lake level experienced a rapid increase of 4 feet during a single seasonal period. Water managers used dam gates on the Truckee River to manage water flow by releasing excess water while protecting downstream regions. The lake water level kept rising despite maximum legal water releases because it was approaching its federally established limit of 6,229 feet above sea level. Tahoe's surface reached its highest point since 2019 by early 2024, which showed a complete recovery from the drought's deep impacts. The sudden and large increase in the lake's water level surprised local residents who had become used to observing the lake's decreasing water levels. The cracked and dry beaches returned to their original state when tourists came back to enjoy the clear alpine waters. The news articles reported California's water miracle as a successful solution that ended the state's long-standing drought problems. The happy appearance of things concealed hidden forces, which proceeded to make their changes. The current water volume that exists above the basin area creates an astonishing amount of pressure. The maximum water capacity of Lake Tahoe reaches almost 39 trillion gallons, which generates billions of tons of pressure on the earth beneath it. The water level increase extends beyond a standard water level rise because it generates additional pressure, which affects the bedrock supporting the lake floor. Scientists studied geological pressure when water levels reached their legal boundary. The material consisted of hydrated rock, which functioned as a heavy weight that pressed down on the fault, which had built up stress for thousands of years. The increasing water levels emerged as a significant obstacle that complicated the region's seismic investigation. The hydrologists and climate experts who studied the lake's refilling process experienced greater surprise than they encountered throughout their professional careers. The consecutive atmospheric rivers, together with record snowpack, created prediction difficulties because models failed to assess their actual impact on extreme climate events. The lake experienced a complete recovery, which demonstrated how water and earth interact in an unstable manner, because sudden surface changes caused underground ground movements. People who celebrated the return of plentiful water failed to understand the hidden effects that developed under the ocean surface. The drought relief brought about by this drastic increase created new dangers, which emerged as another problem. The water's massive weight creates hidden changes that affect geological processes that have remained constant throughout time. The cherished Blue Lake, which offers peace to people, now faces an overwhelming burden. The environmental recovery of Lake Tahoe has reached a point where it causes permanent changes to the lake's ecosystem, which extend beyond water resource management. The new reality compels scientists to investigate the fault that lies concealed beneath the lake's beautiful exterior. The increasing water level did not just restore Tahoe's beauty, it began amplifying seismic signals that seismologists can no longer ignore. Seismic activity on the rise. As Lake Tahoe's waters climbed to their legal maximum, something additional stirred beneath the surface, a noticeable uptick in earthquakes beneath the lake bed. Seismographs positioned around the basin began detecting small tremors and subtle shifts in the Earth's crust, events too faint for humans to feel, but telling scientists. This rise in micro-earthquakes signals that the fault below is responding to changing stress conditions. These small tremors, often measuring less than magnitude 2, are called microseismic events. While they may seem insignificant individually, their patterns matter greatly to seismologists. Increased frequency and clustering of these tiny quakes can indicate that fault segments are inching closer to slipping. Each microquake releases small bursts of built-up strain, but collectively, they may foreshadow larger ruptures. Historical data from around the world show that many major earthquakes are preceded by elevated microseismic activity. For example, the 2011 Tohoku earthquake in Japan was presaged by a period of increased minor tremors.
An earthquake so strong it literally shifted the Earth's axis by about 25 centimeters.
Similar patterns occurred before other catastrophic quakes globally, marking microseisms as vital clues in understanding fault behavior. At Lake Tahoe, the increase in these micro-earthquakes is hard to dismiss. Seismic stations now operate continuously, mapping every detail with unprecedented precision. Researchers track not only how many tremors happen each week, but also their locations and depths beneath the lake bed. The baseline has shifted. The level of activity that would have seemed normal 5 years ago now appears clearly elevated. Scientists interpret this as a sign that the West Tahoe Fault is under mounting stress. The pressure from the rising water, combined with the fault's natural buildup of strain over thousands of years, creates conditions ripe for movement. The fault is restless, recording more frequent slips along its fractures. However, the challenge remains in predicting what these microquakes mean for the near future. Small tremors can either ease pressure or signal a looming big event. Earthquake prediction itself remains an elusive goal. While the increase is cause for vigilance, it does not guarantee that a major earthquake is imminent. Nevertheless, the combination of factors, an overdue fault, maximum water load, and rising seismicity, creates a worryingly rare convergence. Each element alone is significant, but together, they raise the stakes far higher than usual. Researchers keep watching, knowing that this restless activity beneath Lake Tahoe demands respect and careful study. The fault system's response to these stresses sets the stage for potential catastrophe, but the true scale of risk depends on more than just tremors. The coming chapters of this story unfold not only with the earth shaking, but also with the sudden movement of millions of tons of sediment under the lake's depths. This growing seismic unrest beneath the lake is a sobering reminder that nature's surface beauty often hides deep and powerful forces struggling to break free. The science of induced seismicity. The growing concern beneath Lake Tahoe doesn't come from the fault alone, but also from the sheer weight of the water pressing down on it. Water is far heavier than most people realize. 1 cubic foot weighs 62 pounds, and when Lake Tahoe fills to capacity, it holds close to 39 trillion gallons. This amounts to billions of tons of pressure, bearing down relentlessly on fractured bedrock and fault lines deep below the lake surface. Scientists understand that such immense loads can influence how and when faults slip. This phenomenon, known as induced seismicity, occurs when large bodies of water alter the stress conditions of underlying geological faults. It's not merely the weight, but what the water does beneath the surface that raises alarm. Water seeps into rock fractures, increasing pore pressure within the fault zone. This pore pressure acts like a lubricant, reducing the friction that normally holds the fault surfaces locked tight. When friction decreases, a fault primed with accumulated strain becomes far more likely to slip suddenly and violently. Studies around the world have documented this effect. For instance, India's Kena Dam Reservoir triggered a magnitude 6.3 earthquake in 1967, causing tragedy and loss of life. In the United States, reservoirs behind Hoover Dam have produced hundreds of small earthquakes since the 1930s after filling with water. The 2008 Sichuan earthquake, which occurred in China, demonstrates more destructive instances of disaster because researchers believe that reservoir impoundment created near the earthquake site may have caused the disaster, which resulted in an estimated death toll of tens of thousands.
Some 87,000 people were killed, almost 5 million lost their homes.
The ongoing discussions about the topic show a definite conclusion because water loading produces seismic activity, which accelerates movement in fault areas that experience high stress. The cases that present warning signs about what will occur in Lake Tahoe's underwater environment show what will happen at the lake. The West Tahoe Fault, which has experienced thousands of years of geological stress, now encounters added pressure from the water that reaches its maximum capacity at the lake. The water mass produces vertical pressure, which directly increases all forces that operate on the fault system. The combination of water infiltration, which creates pore pressure, and the fault's weakened internal resistance produces a dangerous situation that leads to potential rupture. The process requires extended time to complete. The process operates through a gradual progression that turns secure fractures into areas that exhibit low stability. The Tahoe fault system operates as an interconnected set of fault segments that interact with mechanical impacts from water at different points. Scientists face difficulties in their research because they need to track minor variations that show that the probability of fault failure has increased. The weight of water exerts constant pressure, which experiences small changes due to seasonal lake level changes and different inflow patterns. Even small increases in pore pressure can reduce the amount of force necessary to trigger an earthquake, making previously stable fault sections vulnerable. The current seismic research investigates the relationship between hydrology and geology, which has become essential in Tahoe area research. The hidden pressure from the lake's full state starts to affect fault movements, which will lead to a failure event. The regional instruments detect tiny changes in stress and tremor activity, which reveal that the fault is responding to these forces. The fault reaction demonstrates how water functions as a major element in earthquake physics, which exceeds the common understanding people have about snowmelt-fed lakes. The understanding of Lake Tahoe changes when scientists study its water and the rock interactions, which create a geological hotspot that can produce serious consequences. The science of induced seismicity adds a critical layer to the story of Tahoe's rising waters, which points toward a natural system delicately balanced on the edge of change. The deep history hidden beneath these active processes reveals why this balance is so precarious. Fault history and overdue rupture. Geologists examining Lake Tahoe's underwater environment have pieced together the fault's ancient history, uncovering evidence that it last ruptured roughly 4,000 years ago. Sediment cores pulled from the lakebed reveal the scars left by massive prehistoric earthquakes, preserved in layers below the lake's surface. These geological records tell a story of repeated shaking and release cycles, with clear intervals marking when the fault has given way catastrophically. Considering that typical rupture cycles for faults like this range from hundreds to a few thousand years, 4,000 years without a major event is significant. It indicates that the West Tahoe Fault is overdue, having accumulated strain far beyond its usual release periods.
You can see the fog moving out over the lake there as the sun comes up, and look at that stunning shot as the fog dances over that water. Simply beautiful.
This overdue status creates growing concern among scientists who monitor the region's seismic risk. The fault is not a single line, but a complex system of segments connected across the basin. Each segment can rupture independently or cause cascading failures sequentially, which could drastically increase the magnitude and impact of future earthquakes. This interconnected nature complicates predictions, but also accentuates the potential for a larger, more destructive event. This potential earthquake could rival or exceed the energy released by past events like the 1989 Loma Prieta earthquake, in the San Francisco Bay Area, which measured magnitude 6.9. A magnitude 7.3 earthquake at Tahoe would release over 2.5 times more energy, causing severe damage across nearby communities. The prospect underscores why the fault's overdue status commands attention. For thousands of years, the fault has been locked in a cycle of strain accumulation, holding back the Earth's forces as tectonic plates shift relentlessly. Each passing century adds layers of tension within fractured bedrock, stored energy, waiting for an opportunity to release. This stored strain isn't just a geological curiosity, it's a ticking clock counting down to inevitable rupture. Scientists use various methods to estimate the fault's slip rate and strain accumulation, relying on both surface observations and sedimentary records. These data help establish timelines for when similar faults have ruptured historically, providing clues about future risks. Though precise timing remains elusive, the long dormant period at Tahoe defies typical patterns seen in other fault systems. The silence of these millennia gives a false sense of security, especially to those living and vacationing around the lake. Very few people realize they exist above a fault that hasn't moved significantly in thousands of years, yet is steadily building toward a breaking point. This disconnect between everyday life and geological reality makes preparedness and awareness even more challenging. Even as the scientific community gathers more data and refines models, the certainty remains that the fault will rupture someday. Geological forces operate on timescales far removed from human planning, and strain accumulation inevitably leads to release. The only unknowns are when and how violently the event will occur. This geological certainty, combined with the growing pressure from Lake Tahoe's water rise, contributes to a growing sense of urgency among scientists. The fault's overdue status, paired with the record water levels, creates a convergence of risk that cannot be ignored. The subtle tremors beneath the lake and the unfaltering weight pressing downward are connected chapters of a story moving steadily toward a critical moment. Potential earthquake and tsunami impact. If the West Tahoe Fault ruptures while the lake is at maximum capacity, the effects could be devastating well beyond the initial earthquake itself. Lake Tahoe's underwater terrain plunges drastically, with depths reaching over 1,600 feet and near vertical walls in many locations. Massive underwater slopes made of loose sediment cling precariously to these steep gradients.
You can now take a hike in the water of beautiful Lake Tahoe. California state parks have developed Tahoe's first underwater trail. It's called
creating conditions ripe for catastrophic underwater landslides. An earthquake strong enough to shake this basin could trigger millions of tons of sediment to collapse simultaneously into the lake's depths. When such an enormous volume of sediment drops suddenly, it displaces vast amounts of water almost instantaneously. The result? A powerful tsunami wave that can race across the lake at speeds approaching 100 miles per hour and reach heights of 30 feet or more. Unlike ocean tsunamis that allow hours of warning as waves travel across vast distances, the comparatively narrow width of Lake Tahoe, only about 12 miles at its widest, means a tsunami could cross from one side to the other within minutes. This rapid arrival leaves precious little time for residents and visitors along the shoreline to react. Ocean-facing coastal areas benefit from advanced warning systems and evacuation plans, but Lake Tahoe has no such defenses. The waves would strike almost immediately after a major earthquake, striking communities while they are still reacting to the shaking ground beneath their feet. Researchers found evidence of ancient underwater landslides in lake bed sediments when they studied the McKin Bay landslide, which moved 12 cubic miles of debris during a prehistoric period. The ancient tsunami destroyed all communities near the lake because its destructive force remains buried in the earth underneath the present-day peaceful water. Scientists use contemporary computer simulations to recreate potential outcomes from a landslide and tsunami event that would strike Lake Tahoe in the present time. The predicted waves will exceed 30 feet in height, and they will deliver destruction to coastal towns through their powerful force. The basin structure contains multiple waves that produce tsunami effects, which reflect back from coastal areas to create continuous wave bouncing. The residents will experience multiple waves that cause destruction during a short time period. From South Lake Tahoe to Tahoe City, Incline Village, Kings Beach, and State Line, the danger area covers multiple towns. The locations represent actual territories that families, businesses, and essential facilities occupy while they exist in dangerous proximity to the threat. The lack of an effective warning system endangers these communities because they live above a concealed, deadly threat. The region maintains a constant population of 55,000 residents who experience threefold growth during peak tourist periods. Visitors who lack knowledge about the underwater seismic danger visit ski resorts, casinos, historic sites, and marinas. The region faces transportation system problems, which create operational difficulties for its residents. The lake area has only 2-lane highways, which form a single loop around the lake through Route 28 on the North Shore Highway 50 in the south and Route 89 in the west. The roads create traffic tie-ups, which become more severe during mass evacuations that result from earthquake and tsunami incidents. Emergency responders would face an uphill battle coordinating relief across this fractured landscape. The combination of these elements leads to a situation where an earthquake would generate a tsunami that destroys nearby communities because residents have no time to prepare or escape danger. The natural beauty of Lake Tahoe creates a fatal hazard that transforms into a deadly trap during disaster situations. The human element compounds these natural risks, making the challenge far more complex and urgent. Vulnerable communities and emergency challenges. Around 55,000 people live permanently along Lake Tahoe's shores, a number that surges to over 100,000 on busy summer weekends. Add thousands more during ski season, and the lake's population can triple or quadruple at peak times. These residents and visitors enjoy stunning natural beauty and recreational opportunities, but most remain unaware of the seismic hazards lurking beneath the water and what those hazards could mean for their safety. Despite this risk, the preparedness infrastructure remains severely lacking. Oceanfront areas on the West Coast have invested in tsunami sirens, clearly marked evacuation routes, and public education campaigns designed to save lives. By contrast, Lake Tahoe has no tsunami sirens along its shorelines, no officially recognized evacuation zones, and minimal widespread public awareness about the threat posed by the West Tahoe Fault or potential lake tonic tsunamis.
Through Tuesday morning, that covers the greater Lake Tahoe area as well as Truckee and Donner Summit.
Emergency management operations encounter major difficulties because of their need to manage multiple logistical situations. The lake exists at the point where California and Nevada cross, which creates a boundary that includes 5 counties and their various local law enforcement organizations. The government needs to establish a synchronized reaction plan that combines multiple government agencies because of the tsunami threat, which will follow the earthquake with only minutes of warning time. The physical landscape presents challenges that make evacuation operations more difficult to conduct. The basin operates with only a few 2-lane highways, which leads to road problems that become worse during peak tourism times and result in large-scale evacuations that create total traffic jams, endangering public safety. The mountain landscape creates 2 problems for people trying to escape danger because it controls their escape routes, and it blocks access to safe areas for entire communities. The economic stakes establish a major financial impact. The value of properties that sit along the shoreline area exceeds $15 billion, which includes high-end residential properties, vacation facilities, boat docking areas, and all the business areas that attract millions of visitors each year. The lake investments depend on investors who believe that the lake's calm water surface presents no geological danger, which scientists have increasingly proven to be incorrect through their research activities. Most visitors and residents have never witnessed any scientific publication that discusses the West Tahoe Fault, yet they have not participated in any community meeting that examines earthquake risks. The existing knowledge gap about the threat results in their unsafe situation because the threat can appear at any moment. People need accessible information because they require guidance about their behavior and emergency shelters during situations that develop within minutes. Lake Tahoe has not developed adequate tsunami defense systems, unlike neighboring coastal areas developed through their implementation of evacuation routes and tsunami sirens. The absence of unified emergency response protocols across different jurisdictions, together with narrow roads that become congested during evacuations, puts residents in greater danger. The environmental value of shore properties exceeds $15 billion, which creates major economic implications. Yet both residents and tourists remain unprotected because the public awareness campaign does not exist to inform them about disaster response procedures. The local community needs immediate action to enhance its communication capabilities, educational resources, and infrastructure development, which will protect all residents and visitors to Lake Tahoe. Understanding these human and logistical realities sheds light on the broader challenge, protecting lives and livelihoods where nature's power lies just beneath the surface. The geological threat beneath Lake Tahoe gains new urgency when seen through the lens of those who live, work, and play along its shores. Monitoring efforts and uncertain future. Modern technology gives scientists unprecedented tools to study the West Tahoe Fault and its restless movements beneath the lake. Seismographs positioned around the basin record every tremor, even those too small for people to feel. GPS stations measure ground shifts down to mere millimeters, while satellite imagery tracks subtle surface changes invisible to the naked eye. These advanced networks provide a continuous stream of data that researchers analyze meticulously to detect any signs of increasing risk. Despite this wealth of information, one fundamental limitation remains. Earthquakes cannot be predicted with precise timing. Scientists can identify where strain is accumulating and recognize patterns that may indicate heightened danger, but pinpointing the exact moment a fault will rupture remains beyond current capabilities.
Lake Tahoe is California's most highly curated and micromanaged natural asset.
This uncertainty is frustrating and persistent, a reminder of nature's unpredictable power. The fault beneath Lake Tahoe could remain locked for centuries beyond its average rupture interval, or it could release its strain tomorrow. This variability complicates preparedness efforts, raising difficult questions about how communities should respond to a threat without knowing when it will fully unfold. Scientists emphasize probability and risk, but acknowledge that absolute certainty is impossible. Research teams from institutions like the University of Nevada and the United States Geological Survey continue to study the fault, hoping to improve hazard models and deepen understanding. These efforts include analyzing sediment cores that reveal past catastrophic events, mapping fault scarps beneath the lakebed, and refining seismic monitoring equipment. Yet funding for this critical work remains a constant challenge, with much attention and resources directed toward more famous faults like the San Andreas. The West Tahoe Fault's hidden threat remains largely out of the public eye, overshadowed by faults with more recent or dramatic histories. This lack of attention creates gaps not only in research funding, but also in public awareness and emergency planning. The scientific community urges more focus on this region, given the clear evidence of accumulated strain and rising seismic activity. All experts agree on one unsettling fact: the fault will rupture again. It is a matter of geological certainty, not speculation. A strain that builds over thousands of years must, by the laws of physics, eventually release. The real questions surround when it will happen and how severe the consequences will be. Lake Tahoe's crystal waters conceal a fault long overdue for rupture, now burdened by unprecedented pressure. While the timing remains unknown, scientists agree that the risk is real and growing. Staying informed and supporting seismic preparedness can help protect lives and communities. If you found this video insightful, please like and subscribe for more deep dives into Earth's hidden forces.